What is the connection between the Carnot cycle and absolute temperature? Imagine a perfect engine that can convert heat into work without any waste. Sounds like a dream, right? Well, in thermodynamics, scientists have created a model called the Carnot cycle that shows us the ultimate limits of engine efficiency. This cycle is a simplified, ideal process that helps us understand how heat engines work at their best. But what makes it even more interesting is how it relates to temperature itself. The Carnot cycle involves 4 steps: to our heat exchanges at constant temperature, and to our processes where no heat is added or removed. The engine takes in heat from a hot source and releases some to a cold sink. The key point is that the efficiency of this cycle depends only on the temperatures of these 2 sources. The hotter the heat source, the more work the engine can produce, and the colder the sink, the better. Now here is where the absolute temperature scale comes into play. The efficiency formula for a Carnot engine is 1 minus the ratio of the cold temperature to the hot temperature. These temperatures are measured in kelvins, which is the absolute temperature scale. The Kelvin scale starts at absolute 0, the lowest temperature possible, where particles stop moving. This is different from Celsius or Fahrenheit because it is based on a fundamental physical property. This connection shows us that the efficiency depends only on the ratio of the absolute temperatures. It does not matter what kind of engine or working substance is used. The efficiency can never be higher than that of a Carnot engine operating between the same 2 temperatures. This idea helped scientists define the Kelvin scale, making temperature a measurable property that relates directly to energy and heat flow. The reason this is so important is that it sets a universal standard. The Carnot cycle proves that the absolute temperature scale is not just a convenient way to measure heat but a fundamental property of nature. It links the flow of heat and the maximum possible work an engine can do. Because the cycle is reversible, it also shows that the ratio of heat exchanged at these temperatures is always the same, reinforcing the idea that temperature is an intrinsic property. In practical terms, understanding this connection helps engineers design better engines and refrigeration systems. It guides them to approach the efficiency limits set by nature. So, the Carnot cycle is more than just a theoretical model. It is a foundation that shows us how temperature and energy are connected at the deepest level. It tells us that the absolute temperature scale is built into the very laws of thermodynamics, making it a key part of understanding how our universe works.